Audio's good, video's good. Let's get started. So, welcome everyone. It's been a while. Hisashiburi dane. Let's talk about what we did that you might not know about. So, I see people tuning in. Probably you're interested in Zig, but you don't use it yet. You want to know, like, okay, I haven't really checked in, like, what happened in the last year, and what are those crazy people up to next year? So that's kind of what this stream is for. So, to start, I'm just going to go over some... well, before I start, Loris, do I need to make any announcements before I jump directly into recap and roadmap? Or can I just go straight into the agenda that we already kind of had planned? That's a question for Loris. And while he's thinking about that, I'll just guess the answer to that question. So I think I'm supposed to make an announcement about drumroll software you can love 2026. So I don't know if Matt Knight, okay, this is the Italian one. I think we also have software you can love. There's the Canadian one. Okay, so the website is still on 2023. However, this is an announcement. There will be a software you can love Vancouver in 2026. So put that on your mental calendar. I don't think we have dates yet. But I know that Matt Knight has already started doing the organizational work. So yeah, kudos to Matt Knight for taking that on. And yeah, just get ready, because when that's going to be a really nice event. So, what's next? I'll talk about the other announcement maybe afterwards. So I'll jump next into kind of reviewing some of the accomplishments that we've done in the last year. So if you don't know, we do put a lot of work in these release notes, so you can get a lot of the information I'm about to give you by following it. But hey, this is text. Some people like text, some people like video, and this is for all the video people. So here you go. Let's just review some stuff. So one thing that we've focused on recently is package manager, and so some people are already using that. And if I demo my little project here, I think I already have a binary I can run. Oh, there we go. So this is just a little, I'm playing with a little like immediate mode UI. I'm doing some font rendering. This is using Vulkan, trying to learn Vulkan stuff. Eventually I hope to turn this into like a music thing. But what I want to show you now is just a little feature that we added that maybe if you don't know about it, you really need to know about it. And that's Zig Fetch. So Zig Fetch is part of our toolchain for the package manager. And what I want to highlight right now is this particular workflow. So in this example, I have, let's look at my dependencies briefly. So I have this dependency here on the shader compiler. This is a package made by Mason Ramelli, which compiles GLSL into SpearV. In the future, we actually will have a Zig backend for this, and actually we have a proof of concept that you can play with. Shoutouts to Ali Chagri and Robin Voder for working on that. But in the meantime, we have this shader compiler, and I need to update it. So one of the workflows that you can now do, which is pretty handy, is you can just take that. If you want to just update to like the latest master, for example, I can just do Zig fetch, save, and I do git plus, and then this link, and that's going to get me. It's not going to link to the master one. It's going to resolve it to a commit and put that commit in the file. So the change that actually made was it's now fetching with Git protocol. It's locking it into that particular commit, and it calculated the hash for me and installed it on my system. So now I'm ready to go ahead and rebuild. You can see that change there. So if you haven't been using Zig build fetch, that's a nice workflow. So just keep that in mind. Let me see what's next on our agenda here. I have a little. We had originally planned for Loris to kind of like walk me through these, through the agenda, but now I gotta run the show, so I gotta scroll up a little bit on my notes. 1 sec here. Yeah, and we will do QA at the end, so feel free to get your questions ready. Okay, that was Zig Fetch. Let's move on. So the next thing, I'll keep these highlighted. The next thing that I want to highlight is the fact that we've now made x86 backend enabled by default in debug mode. So if you don't follow our devlog posts, it's kind of nice. There's an RSS feed. They're all just kind of on one page here. And so there's this. This is the post where we announced it, but I can give you a little demo here. The milestone that we've gotten to, specifically Jacob Young has gotten us to, and Matthew Lug, especially with like a lot of the front end improvements, is that the self-hosted x86 backend, the one that does not depend on LLVM, is at 64-bit. It's now robust enough that it's now the default. In fact, let me show you something. So here I have. Let me actually just use one terminal since I'm streaming here. There we go. Let's take a look at running the behavior tests, and just to make it even, I'm going to disable these because those applied not to LLVM. So I have a build here of the compiler, and sorry, it's over here. And if I run the behavior tests with LLVM, we can observe how long it takes, and we can see how many tests it runs. Okay, so that was 1,000. Let's just take note of this little data point here. Oops. Okay. And now, if I get rid of this FLLVM flag, it's now doing the default. And because I'm on an x86 computer, default will use our own backend and will skip LLVM. So you can see that was a lot faster. And we can see actually it's passing more tests. It's skipping fewer, and it's actually having slightly more coverage than LLVM. So, you know, it's the story is a little more nuanced than that. But the point is that the x86 backend is, if anything, more robust than the LLVM backend at this point. It's not strictly better, but it is mostly better. And so now it's the default. And it's the default because, as you can see, it's a lot faster. Just to do a quick little demonstration of that, if we can go into here, let's see my hello world here, okay. And let's do build.exe hello. Yeah, that's what I want. And then with LLVM. Yeah, okay. So you can already see it's a little faster, but let's race those. And if I just collect about 5 seconds of data for each one, let's take a look. Whoops. Okay, so we can see that the using LLVM was this one, and by not using LLVM and by compiling with Zig's backend instead of LLVM, we went down from 1 second to 225 milliseconds. We used less memory, and then this is kind of just an explanation for why it's faster. Yeah, shoutouts to Matt Knight for naming for the name. We actually named this CLI tool on stream, so you have Embedded Boy to thank for that. Okay, so that's the x86 backend. It's now the default, so try it out. This is going to debut in 0.15, which will be released in about a month. Plan is for August 1st is their tentative release date. Here's a good question. If your project uses a C library, do you still need to use LLVM? No. I don't remember what the default is. We might still default to if you have any libraries. No, we don't. Okay, no. The answer is no. This backend works fine if you link C code. You can still use it. Yeah. In fact, I'm pretty sure the project I just demoed a second ago with that little window was using the self-hosted backend. And that's using like Vulkan C libraries and stuff like that. And yes, it is also the default for running build.zig. So your Zig build commands will now be faster as well if you're on x86. And now I know you might be wondering, what about if I'm on one of those Mac computers? Well, hold on. We'll get to that. All right, why did I lose my little agenda notes? Hold on, sorry. We'll get there. That's a foreshadowing. Okay, but for now, let's move on to a different topic. So I want to show you another thing that is now happening by default. So if let's look at some C code. So one thing that a lot of people discover Zig for is ZigCC. So we have this. It acts just like a C compiler with caveats. And sorry, before I move on to this topic, I do want to address Casey Banner's point, which is a good point. I forgot to mention, on Windows, x86 backend is not the default yet because we need to make some cough linker enhancements before we can enable it by default. So that is a caveat there. We'll get there. We'll get there. Yeah, one thing at a time. And that's the answer to this question. So the answer is it does work on Windows, but the problem is we need to make some linker enhancements before before we can turn it on by default. So that's coming up. I don't know if we'll get to it in time for 0.15, unfortunately. But it's definitely a high priority issue. Okay, so let's talk about ZigCC for a moment. So one thing that's important to understand about ZigCC is that it's not trying to be, while it is trying to be compatible with the C compiler command line interface, it's not trying to be literally exactly the same as Clang. In particular, we have different defaults. And the defaults kind of map to Zig's paradigm. In fact, the way that this works is that we collect the C command line arguments, and then we translate those into the equivalent of what Zig command line arguments would specify, and then we lower that into commands that we pass to Clang and all things like this. And that's kind of a crucial part of what ZigCC offers. I'll give you an example. So if you do ZigCC like O2, what actually happens is in the command line parsing, we interpret O2 as release fast. But if you pass in O2 fsanitize equals, I don't know, I think it's just, I forget what the command is. Maybe it's just fsanitize. If you enable ubsan, oh, there we go. If you do this one, we interpret this combination of flags as release safe, and then later we probably just lower it to exactly these flags again. So why do we go through that maybe seemingly unnecessary like middle state? Because that middle state affects all sorts of other stuff. So for example, by default, you're getting debug mode, and because you're getting debug mode, we do enable undefined behavior sanitizer. And one of the things that we recently added, shout outs to David Rubin, I believe that's your name, Rexicon. We now have nice printing for this. So for example, Somebody shout out their favorite undefined behavior. How about signed integer overflow? Gray header had it. Good job. Okay, so we're gonna do argc compiling a file without a trailing new line. Oh man, that's a really good one. Okay, we're gonna do argc plus 1 to the 31. Okay. I guess I could have just done that, huh? Okay, so let's try there we go. So let's see what happens if we compile this. Oh, I'm too Zig-pilled for this. Thanks, Matthew. Okay, so let's try compiling this code with zigcc. Okay. There's a little spoiler, libubsan there. Now, some of that stuff only had happened once, and I'll show you that if I make some changes, such as by adding a pointless comment, that was an instant rebuild, because those things that took a while to rebuild, those were just like support libraries. Those only have to ever be done exactly once per target. So I pretty much never have to do that again until I switch versions of Zig. So no, let's try running this example, and it's going to. Oh, I hit undefined behavior before I hit the undefined behavior that I intended to hit. Oops. That's a perfect example of what I'm trying to show. Well, just for fun, let's try to get the intended undefined behavior, but I guess that's why I instinctively reached for Python here. I just didn't even trust C even a little bit. Okay, so let's try that. Wait, long? What? Format specifies type int, but the argument has type long. Why is it long? Oh. Wait, what? One doesn't fit in an int? What do you mean it doesn't fit in an int? Of course it fits in an int. Oh, I need -1? Oh, okay, yeah, off by 1. Classic. Okay, so if I run my example, oh crap, I wanted 6. Oh, I have to rebuild too. Okay, there we go. Well, this is the example I was trying to show. Now if I pass an argument, I get a undefined behavior, and we get the actually nice panic with a backtrace, with a message that explains the problem. So anyway, point being, the default of zigcc already was this, turning on undefined behavior sanitizer. The new thing that I'm trying to show you that we did recently was adding by default the undefined behavior sanitizer library, which tells you the problem. So that's a lot more friendly for beginners who are learning C. So I would argue to you that zigcc is a great way for students to learn C programming, because this is so much more helpful than just getting like wrong behavior at runtime, or like you compile with optimizations on and then it stops working. And then yeah, and the way this is implemented, by the way, it's literally just calling panic in the Zig standard library, and then the Zig standard library is doing the stack tracing. So it's pretty neat. It's pretty nifty. Okay, so that was undefined behavior sanitizer with zigcc. Moving on, let's look at some language changes. So again, I want to tell everyone that if you read our release notes, this is a great way to upgrade your code in response to language changes, Because, for example, if you go to language changes, and in fact, let's go to a different one. Let's go to this one. Actually, let's go to a breaking change. This one, for example. Okay, so we'll tell you all about all the language changes. For example, export changed to be a pointer now. We'll give you a reason why we changed it, and then we'll tell you if your code looks like this, then you can update it like this, and now it will work. And in the best case scenario, we'll also give you like a compile error so that you can search for the compile error. I don't see too many of those right now, but anyway, point is, upgrade guide will help you if you're trying to upgrade. But I want to show you one of my favorite new features in Zig, which is labeled switch. I think to demo this, I'm going to open up the Zig's tokenizer. So for those who aren't super familiar with compiler development, tokenizer is kind of like the first thing that a compiler does to your source code. It just looks at it and figures out like what's a space and what's a keyword and what's like punctuation and stuff. So Zig's tokenizer, it's gonna input a string and it's gonna output an array of tokens. Zig's tokenizer is 1,776 lines, and it's basically a state machine. Pretty much every tokenizer is a state machine. So here's our like state. Here's our possible states that the tokenizer can be in. It's just an enum, and the heart of a tokenizer is just basically this. It's just a big loop that switches on the state and what byte in the stream did you look at next. Now, if you haven't seen this language feature, check this out, because this, I think it's super cool. As you may know, Zig does not have goto. As you might not know, Zig actually used to have goto. Fun fact. Yeah, we deleted goto. I was never against goto in principle, but what I determined is that it's redundant with labeled break, labeled continue, and especially now that we have labeled switch continue. So what you might find interesting here is that, let's look for lowercase state. And defer, that's a good point, yeah. Yeah, so what you do is you label the switch statement with a label, and then now it's eligible to be continued like a loop. So what's super funny about this is that when we switch, we're actually switching on a constant value. We're just switching on the start state. And we don't even store the state in a variable. See that? There's no variable that stores the state. So this control flow just goes straight to here. It doesn't even have to check a variable or something. So then we immediately start looking at the next character, and we handle like the end of the string, or we handle a space, and every time we terminate one of these blocks, we do a continue, a labeled continue. So this basically just jumps back to the switch with a different value. And so, but what's neat about it is that if this value is compile time known, it doesn't have to be. But if it is compile time known, that is just a goto. So for example, this is like continuing with string literal enum value. That's going to jump directly to here. That's a goto. It's just a goto, but it's structured, so it's not going to like not initialize variables or something. And we can also find examples of not compile time continues. Well, a lot of them are compile time, but point is that generates really ideal machine code. And even if we use a runtime value, which I didn't find an instance of, but if we did, what's nice about that is that it will then do the branching logic at that location and then jump directly from there to another location. So what that does is it moves, instead of there being like a while loop here, where there's a really like mispredicted branch, right? Because this switch here will be mispredicted if it's in a while loop, because it's not likely that the next byte in the source code is going to be the same byte as the previous one. That's kind of the point. But when you move all of the branching into these inside here, where it jumps directly to the next place it needs to go, what you get is more branches to be predicted. And well, here they're not even being predicted, they're just jumping directly, which is nice. But even if they're runtime, you end up with more branches that can be more likely to be predicted. So it really helps the branch predictor to use this pattern. And in fact, when we switch the tokenizer to this pattern and to take advantage of this new feature, does anyone remember, was it this one? Okay, yeah, so this person updated the Zig tokenizer to use labeled switch, and they reported 13% speed up just by doing that switch. So that's pretty neat. And what I really like about this is that not only is it faster, but it's also nice. Like, I actually think that the source code reads better this way than with a while loop. Because if you just go from here to the end of the loop, you kind of have to check two places to know where it's going. But even if I'm in the middle of this big state machine and I see this, I know exactly where this is going. I know it's going to right here. I don't even have to like double check the top of the while loop, for example. So I really like this this syntax. I'm happy with this. Nice. Nice. Okay, well, let's move on to the next topic. So that was labeled switch, just a little highlight from the last year. Okay, yeah, next I'm going to highlight some toolchain improvements. These come from Alex Ron Peterson, our newest core team member. And he has improved our target support a lot, in more ways than what I'm about to show you. But what you might have noticed, or maybe not if you're just tuning in out of curiosity, is that our download page is quite a bit bigger. I can't even fit on one screen anymore. So in addition to Windows, x86 64, ARM 64, 32-bit, all the Linux stuff we have, actually adding Long Arch and S390X, these are thanks to Alex RP as well. But not only that, he also went in and learned how our glibc and muscle libc strategies worked. He adapted them for FreeBSD and NetBSD, and then look at that. Now we even have all these, and these are all automated on the CI. So now every day-ish, if you're on any of these operating systems, you got to build a Zig, and that's just you're gonna build just no dependencies other than libc, so you can just download that, unzip it, and you're off to the races. And so we already have the ability to cross-compile these things. So for example, if I just run like the standard library tests, I could do FreeBSD, for example. But yeah, I think pretty sure this worked before. But the thing that works now is we also provide headers. I guess I need libc. We also provide headers. So, okay, well, I'll have to look into this. This seems like a recent regression of sorts. So that means that I should be able to demo, I think, I should be able to do our C example then. Okay, so that's just a standard hello world, and I can even do zigcc hello. So this is for native, okay, obviously. But now we can do, let's do a weird one. PowerPC, big endian PowerPC 64 FreeBSD. How about that? And we even have undefined behavior sanitizer. Amazing. Okay, so I'm hitting that same problem. I'll have to figure out what's going on there. Does anyone know already? I haven't actually tried this before. I mean, we got builds, so am I supposed to do I don't know. Anyway, this is not going to be a problem. I'm sure we can get this fixed before the release. So sorry for the bad demo, but yeah. Shout outs to AlexRP for all this toolchain support. So we're going to be looking at all the targets kind of moving up the tiers with this next release. More support, more testing. Jacob Lee saying I need LC for ZigCC, but what you might not know already, Jacob Lee, is that is the default with ZigCC. That is fully redundant to pass in LC with ZigCC. I also tried it over here. Yeah, I don't know. I think it's probably just like a recent regression of sorts. But yeah, we'll get that fixed. No problem. Okay, so. Oh, that's what it was. Yeah, I knew there was something I was forgetting. Okay, thanks, Alex. And thanks, Matthew. Right, so yeah, he mentioned this too, and I just totally forgot. So part of the Zig target triple is operating system versions. And so he made the decision to support starting with 14.0. So there we go. That'll work now. There was some reason that it was going to be a bunch of trouble to target 13. Anyway, so there we go. And I can't run this because this is a FreeBSD binary. Let's see if file knows about it. Well, yeah, I also can't run it because it's PowerPC. Okay, there you go. So we just made a hello world for 64-bit big endian PowerPC for FreeBSD 14, which is the newest release. Pretty cool. Pretty cool. Yeah, and Alex did a great job contributing to the libc toolchain that we have for keeping this stuff up to date. He did a good job keeping all of our like we have these wiki pages for updating libc. And so like here's what you have to do when glibc updates, and like here's muscle, and then now there's a section for FreeBSD. And now there's a section for NetBSD. So he's done a great job documenting everything he's doing and making it a repeatable process for us all. So yeah, that's some really good work. Okay. Yeah, thanks for figuring that out, Matthew. That's good. Okay, moving on. So that was, yeah, some toolchain updates. Yes. Okay. Let's move on. Did he get a dedicated welcome blog post? Yeah, I did that for sure, didn't I? Don't tell me I forgot to do that. Oh, wait, I thought I did that. Oh no. Okay, well, that's on me. Why do I remember typing a welcome blog post for him? Did I do it in the release notes, maybe? I don't know. Did I do a draft and never publish it? Oh no. Okay, that's my failing. Did I dream doing that? Okay. Well, let's move on for now. Okay, so let's talk about file system watching. File system watching, yes. Okay, how do I even want to start showing this off? Well, I think I'll start by showing our workflow for building the compiler. I'm on master branch right now. Let's undo these changes. Yeah, we will. Don't worry, I won't forget about saying this. Our workflow. Sorry, let me back up. Right now, I have another branch that I'm working on that has required a lot of changes. It's required working through a lot of compile errors. And let me show you what that workflow looks like a little bit. So there's, yeah, and if you haven't been paying attention to Zig recently, this is the part where you should like put your I don't know, put your Counter-Strike down and pay attention for a second. So here we're gonna build the compiler. I'm gonna turn off some stuff I don't want. I'm also gonna turn off like building an executable. I just want compile errors, and I'm going to ask the build system to stay alive and notice when any input files change and rebuild. And I'm also going to enable incremental compilation, and I'm going to make compile errors print at the bottom for convenience. So this is going to build the compiler, all of it, from scratch, and it's doing that right now. Nothing is cached other than like compiler RT, so it's rebuilding like 100% of the compiler from scratch, 15 seconds. And that was with our own x86 backend that I was demoing earlier. So that's about 500,000 lines of code. Done. Now, let me put this on the bottom for a second. And let's go start editing. I know I passed no bin. I'm only looking for compile errors right now. So let's say I want to go in and I want to actually delete the breakpoint built-in. I think it's a bad built-in. I'm gonna delete it actually. So let's go find that. Okay, I think I found this. So I'm just gonna delete this code here. Okay. I got some errors. Okay, let's keep that up there so I can see those. Well, that makes sense. I just deleted something, so I'm going to get an error. I better go into here and delete that then. Okay, that had to rebuild quite a bit actually. Let's keep going. So now I'm in this file. Okay, I gotta delete this. Oh, okay, that one was pretty fast. Gotta delete this. Gotta delete. What's going on here? Switch must handle all possibilities. Okay, so I need to delete some breakpoints. Okay, now you get the point I'm making here. I am getting instant feedback on all these changes that I'm making. Like if I want to go in here, 1605. So I'm going to handle this compile error now. Save. Okay, that one took a little while. We're going to have to redo some x86 backend stuff for some reason. Let's see, what else? Let's delete from here. That one was instant. Print here. Delete from there. Instant. So what you're seeing right now is, I'll show you my command again. You're seeing a combination of turning off building a binary, having the build system watch for changes automatically, incremental compilation, and just showing all the compile errors at the bottom. And what I'm trying to show you is that you can get instant compile errors in your workflow by setting this up for yourself. And that is new and as in the last year. So if you don't have this set up, I highly recommend the setup, because you're going to it's really going to unlock like your own potential as a software developer, because when you get instant feedback like this, you lose the temptation to alt tab over to Firefox and like look at social media or something. You know what I mean? Like you can stay focused a lot better. Yeah, worth noting, ZLS can leverage this feature, so you get squigglies, right? Is that how it does it? Yeah, this is in 0.14. And it's also, correct me if I'm wrong, Matthew, but I think it's improved since then. So like bug fixes and enhancements coming out in the next release. But also, That's the next topic. Okay, let me just see if there's any questions here. This example is goofy. I'm not actually intending to do that, so you can just forget about that. That was just an example. I'm just trying to show off this combination of stuff. Clearing the screen for printing the errors, that's probably a good idea. I think we have an issue open for this. Another idea would just be printing a blank line. Oh, yeah, we'll get there. We're working on that. That's the easy stuff, you know? That's the stuff that you can... It's like kind of the paint on top that's easy to tweak. Yeah, so if you don't have this workflow, I recommend upgrade, figure it out. Make sure you get this workflow because it's really, really nice. Now, you might have noticed that... oh yeah, and Matthew just confirmed what I said. So this is available in 0.14, but there's been enhancements since then. So it'll be good to get the upgrade. I hope that you can map that in the quick fix list in Vim. I would love that. I don't know how to do that right now. I do my best not to edit Vim plugins. Okay, yeah, now this is the topic I was about to get to. So you may have noticed that I disabled outputting a binary. So this is the equivalent of passing no emit bin to build.exe. And obviously that's not ideal. What we want is we want to get instant rebuilds that we can also test. And that does work experimentally. So I can... actually, let me just try this. And I'm going to try this knowing that it might fail. So just keep this in mind. But going back to this DAW project, I think I need some like Vulkan stuff in my path. I might not be able to build this. It might have to require updates, so bear with me here. But I will try turning it on. And this is with creating an executable. So I'll make a change and then see. I don't think I have Wayland enabled, so I need X11. Oh, is this because I made that change? Oh yeah. Oops. Well, I updated the shader compiler, so I have to rebuild it. Let's just let that run for a second. I think it should be fine. I got a pretty beefy setup over here. But the point that I'm getting at is the thing that we're working on next is making this also work when you're outputting an executable, not only when you turn that off. So yeah, we'll get there. As you can see, the front end is working quite well. And the thing that's holding us back is the linker. So we need to make some linker enhancements, and then we can then you'll be able to do this while generating a binary and testing it and getting instant rebuilds. As for this question, I think I merged a fix to that last week. So if you haven't checked in a week, try now. But so I've done watch on this. Now this generated a so let's just do a new window actually. Okay, so I can run the program. It's still watching it. So let's go ahead and make an edit. I don't know what kind of, I haven't touched this project in a while, but let's just let's make it read the wrong font name and crash. Okay, so I actually hit save on that, and now it should crash when I try to run it because I can't find the font. Okay, now see this said success, but it generated a not viable binary. The linker did a miscompilation there, so that's a problem. And if I go back, it's still, yeah, it's not good. So as you can see, this feature is not quite ready for prime time when it comes to generating executables, but it will be after we make some linker enhancements. In particular, that one was for the elf linker, and earlier we noted that we needed cough linker enhancements to make x86 backend enable by default for Windows. So yeah, we'll need to make some nice linker enhancements to unlock some of the next things coming up for us. Was that all I was trying to say about watching an incremental? Let's talk about bugs. Yeah, so we recently, until recently, we had a bug that caused not same file system error on Linux. I believe that has been fully fixed as of last week. However, on Mac OS, there's still a problem with the watch system. Unfortunately, Mac OS doesn't give you very good watching primitives. Linux actually gives you pretty good watching primitives with the FA, what is it, FA notify? This API is pretty nice actually, especially after like 5.1. But macOS, unfortunately, is not good. So we did the best we could with only using like macOS syscalls. Problem is that it only detects like editors that atomically update the files. If they actually just make writes, then it doesn't detect updates, which is a problem. So our plan is to switch to using whatever that stupid foundation is. I forget what it's called. There's some like framework you have to link for watching like file system updates, and it I don't know. I think it just watches the whole file system or something in user space, and then you basically are querying that database. But I guess, yeah, FS event stream. So I think we just basically gotta DL open this thing in the build system, and then that'll fix the problem. But that's not done yet. So file watching on macOS is it's got a big asterisk next to it. What else? I think there was one more thing I wanted to mention here. I'm sure I'll remember it in a moment. Okay, I think that is my segue. Okay, let me briefly speak about... Yeah, we'll get there. One more thing before I segue into that. Okay, translate C. So for a while, just kind of quietly in the background, Veka has been working on a translate C package for Zig, which is based on his C compiler, which is called Arrow, or Arrow, I don't know. And it's done. So this package actually is fully compatible with our existing translate C test suite. It's ready to roll. So right now, when you use, let me just go into, oops. Let's go into a directory here. So here was our example from earlier. Okay. If I do Zig translate C, it's going to spit out some text. I guess I have to link libc. It's going to spit out some text, and there's a bunch of crap that C defines, but we're also going to get our main. And hey, there it is. So this is our code translated into Zig. And it actually works. So if we, like, for example, do this, and then we do build. Actually, I can just do run. There you go. So this totally works. This is based on Clang. So we are using Clang AST to iterate over it and then translate that into Zig. What Veka has done is completely bypass Clang. So this package works on his C compiler, which is written in Zig. It's pure Zig. And it's up to par. So for example, wait, I don't actually have this package integrated yet, so I would have to spend a few minutes setting up an example. But the next step here would be changing it so that when we run this command line, it just doesn't even use clang at all. It just uses ro-libc. What's interesting about this is that we actually could hook this up to the backend. So for example, we could implement like zigcc that doesn't link clang at all. And it would just do RO translation and then run that through Zig, and then we get something out the other side, which could be a fun stream, maybe a follow-up stream or something if we have a whole bunch of time remaining. But we're not going to do that right now. Suffice to say, we're well underway for eliminating our clang dependency. We're well underway for eliminating our LLD dependency, and we're well under the way for eliminating our LLVM dependency. And with that, I think that might be our segue into revealing the secret. Okay. So, for people who haven't been following along too much, don't worry about it. For people who have, you might be maddened by the fact that Jacob Lee has been teasing us all with his secret project, and he's not telling us what it is. Well, he told me finally so that I could demo it for you on stream. So I know the secret, and the secret is it is a ARM64 backend. Ta-da! Oh wait, I'm not in the right directory. Ta-da! Okay. Let's play with it. Let's see what it can do. So I'm gonna build it from source. Okay, so I'm running build the compiler. Okay, it's built. And so now we have a stage 4 that can do ARM stuff. So what should we do? Let's try running the behavior tests. Now I'm gonna have to add some flags here since it's a work in progress backend. So here we're saying target ARM64 Linux. We're saying don't use the LLVM backend, obviously. Zig's debug mode is actually pretty sophisticated. Zig's debug mode has all sorts of safety checks and all these fancy stuff. So by passing release small, we actually make the task that the backend has to do smaller. We also don't support compiler RT yet. That requires a bunch of ABI stuff that's not done yet. And finally, I'm going to run the tests in QEMU so that we can actually run the behavior tests. Okay, that was fast. And there you go. So we're passing 1,054 tests and skipping 1,029. So a little over half of the behavior tests are passing. Now, don't get too excited because a lot of these are testing the front end. So kind of like once you pass the first test, you pass a bunch of them. But it's good progress. And now the other thing that's interesting about this is that Jacob Lee has shared, well, you can also just look at the code. It's public. Oh, Matthew wants to see an uncached build. All right. Here's your uncached build. Okay, yeah, that was definitely cached. Okay, it's still fast. Is this still uncached? Well, this is a debug build of the compiler. So we're actually kind of measuring the machine code quality of the x86 backend. So that's what that's doing. We're measuring the machine code quality of debug mode x86 backend. Okay, anyway, what was I saying? Right, okay, so Jacob Lee has shared some of the cool things about this backend, and it's kind of a fresh take on the backend. It's got some unique ideas in it. He's playing with different data structures. He's already done a couple of rewrites to try different things. So he gave me this little demo to show. So here we have a file just to show a couple different kinds of code gen. So the idea here is that here we're getting 4 arguments, but we're kind of passing the arguments shifted one to the left. Here we're getting 4 arguments, but we're kind of passing the arguments shifted one to the right. And there's just kind of a neat little optimization demo available here. So if I run the backend, I can compile an object file. I can do an object dump on that. And let's take a look. So let me actually try to separate these. Okay. So what's interesting about this is select. Okay. Notice here that we've moved these registers in order 0, 1, 2, 3 in order to call the next function right here. But in this one, it does it backwards. See this? 3, 2, 1, 0. So this allows it to use exactly only 4 registers to make this call. Exactly only 4 registers to make this call. However, for these, it's actually a rotation. And so there it's like mathematically necessary to introduce a temporary. So then we have a temporary and then 4 registers, which makes sense. But it's just kind of neat that already it's a debug backend and it's doing just little things like this that are nice. And so, yeah, it's still too early to make, concrete claims. But I will say that our goal, and Jacob can get after me if I shouldn't say this, but our goal is to not only beat LLVM at compilation speed, but also beat LLVM at machine code quality for debug mode at the same time. And it's looking possible to me based on Jacob Lee's work. I'll give him a minute to object. All right, let me look through some of these questions. What's up with this QEMU thing? I'll answer this question. So part of the Zig build system, well, let me back up. Not talking about the build system yet. Part of Zig's unit testing system is, and let me go to just like a fresh example. Okay, so if we just make a unit test, it's just going to be empty, okay? Just an empty unit test. So if I do zig test example.zig, it's going to run that test. And the default thing it's going to do is just run it natively. But you can just tell it to run something with a different command. So if I just say like echo, for example, that's just going to run echo and nothing else. If I do this, it's just going to print the name of the test. So another thing you can do then is just give it a different command like QEMU arch64, and now it's going to just run. It's going to run this in ARM64, but obviously that's not right. So then I would also need to do this, and then there you go. You can now run unit tests for a foreign architecture. This is also hooked up into the build system. So for example, if I do build, I just get the help menu here. Right, so this option is always available in Zig build. You can just enable this flag, and if you do that, then when you try to run tests with the build system will detect when it might need to use QEMU to run your binaries, and it will just do that. Or you can just not set that and not worry about it, but it can be handy. Generally, the rule of thumb that we have here is that we'll add integrations for popular projects like this, but they'll never be enabled by default. Okay, so let's see what else is going on. What about release mode? Yeah, the plan right now for the foreseeable future is the default for release mode will still be LLVM. However, in a long-term future, I can envision a world in which we have optimizations and just completely part ways with the LLVM project. But that is probably a post 1.0 idea. I don't think I'll try to do that before 1.0. That is not a question for me, is it? Okay. So I think maybe we can move on from that topic, and feel free to ask me a question later in the official Q&A section, and we can revisit the topic. But for now, I'm going to move on. Okay, yeah. So next, I think I'll show you a little bit about what I've been working on. Yeah, I'm fine with it. You can do that. Okay, so what I've been working on is resurrection of async awaits. However, it's so much more than just that. I actually gave a talk on a lot of these topics a couple weeks ago in Amsterdam. And I will post the talk here when it's available. It's not available yet. I put all my talks on my website in order. But I can also just go over some of the basics again. So here's a branch. I'll preface by saying I feel like it's solved in theory. Like the stuff that I did with async await before, it never felt finished. It never felt like it was good enough. I feel like there is a path towards realizing my vision with this new thing. So I'll preface it by saying that. And the idea is kind of simple, actually. It's just, for some reason, some of the simple ideas, they're just hard to think of. Wait, this is not what I wanted. Okay. So, you know how in Zig programs you always have to pass an allocator everywhere? Okay, well now you're going to have to also do that with I/O. I/O. What is I/O? I/O is everything, pretty much. So like async is part of I/O. Await is I/O. This is a little homage to the Go programming language. It's basically async without an await. It's just like crippled async await. We also have cancellation. I'll get into that in a minute. But then things like opening files, doing networking, mutexes, conditions, timing. And there's going to be like much more. It's all related. Anything that can block the current thread of execution, including like large CPU tasks, they belong here. And so what this means is that in Zig projects, kind of one of the first things that you'll do, you know, in like your main, is you'll either, well, you'll either choose or you'll implement a I/O implementation. And I have an example of this. I think I'll just find it on my gist. Oh, here it is. Okay, so I put this together already. So kind of in main, one of the first things you'll do, you pick your allocator. This is a familiar pattern, right? Okay, you're also going to have to pick your I/O implementation. So maybe you pick an implementation that's based on a thread pool, okay, and then you grab your I/O from there. Or maybe you pick your implementation from a like green threads event loop, and then you get your I/O from there. Doesn't matter. In this example, I can uncomment this one and comment this one, and the program will have the same output. Not the same behavior, but the same output. And then you're going to get basically async await. And keep in mind that once the keyword is dropped, these can go to being a regular function name, so they won't have this weird syntax. It's just a function call, okay? Now, the point of this, and this is kind of like a lot of demos all squished together into one, but the point of this is that you can encode into your logic doing stuff in parallel. So here I encode the idea that I can calculate the first half and the second half, and then only later do I need the results. So I start this stuff, I do a bunch of other crap while I'm waiting, and then now I need the results. This allows you to encode that logic, and then the user of this code, which could be a different person, gets to decide how to execute your logic based on which IO implementation they pick. Exactly like how you take an allocator as a function, and the caller gets to decide how you allocate your memory. There's a ton of benefits for this. Just off the top of my head, resource leak checking, testing, better testing, not have to write your code twice depending on whether someone wants to use it in event loop or not. That's the big one. There's a bunch more. What am I forgetting? It's just so nice. And also by doing this in bring your own operating system, that's a good point. So you can take a package that used to have a dependency on the operating system, and now it only has a dependency on the IO interface. So if you make your own operating system, all you have to do is implement this interface, and now you can use all this Zig code that's now works on your hobby operating system. No one even had to care about it. They just had to use the interface. Yeah, and then because it's in userland and it's not like keywords of the language, it actually becomes a lot easier to implement some of these like niceties like cancellation and select. So for example, I implemented this queue. This is equivalent of a Go channel. I also was able to implement select in userland in the interface. So for example, and this works, by the way, this is a working example using the branch I just checked out. So select is a feature where you give it multiple asyncs, and then like the first one to finish, it gets run. Now what's interesting about this one is that it's also combined with cancellation. So you can see here we start these three things, and then we defer a cancel. Defer cancel, defer cancel. So whenever we return from this function, all these resources are cleaned up and everything. So what I think is interesting about this is that Zig is not a garbage collected language. However, there is pretty minimal boilerplate here compared to like what this would look like in Go, for example. I mean, arguably it might even be longer in Go because of the lack of try. So to me, this is the dream, because now I can encode, I can make like a reusable package that doesn't decide which operating system it has to run on, and it doesn't decide what order things have to be run in. Like if I can do two things at once, I can encode the fact that I'm doing two things at once. And if my user just wants to like use my Zig library along with some like basic C code, they can do that. All they have to do is choose the IO implementation. That's the dead simple one that just does things like it does things eagerly at the async, and then await becomes a no op, and then it all works. So this is the future of async await. We're headed this way, and other programming languages can't do this because they don't have Zig's single compilation unit strategy. So all that work we put into incremental compilation, all that work we put into making our single compilation unit strategy work is what's enabling us to move forward in this way. And it's also going to depend on restricted function pointer types, which is quite an interesting proposal, which, long story short, just makes this code be not have some downsides that it would otherwise have. Where am I going with async await? What am I missing, Matthew? Are you paying attention? I think I hit all the points here. Right. So then the only question there is, what about coroutines? And that just becomes a question of, is it possible to make an IO implementation with stackless coroutines? And that's, at this point, it's a separate follow-up question. So that's, I'm thinking likely yes, because we'll need to be able to do that for certain targets. Like if the target doesn't have the ability to implement yield in user space, then we need the ability to do it with stackless coroutines. But they will become a much lower level primitive that users usually won't touch. Like they will become an implementation detail of an IO implementation, and not something that users need to care about at all who are writing reusable packages. So only like standard library authors or like people who are creating like alternate IO implementations or other advanced stuff will care about these stackless coroutine primitives. Let me try and click this link. Yeah. Okay. Why does single compilation unit enable this type of async? Particularly because what we need, it all has to do with stack usage. So the problem is that whenever you do two things in parallel, you are now heap allocating the stack of the other thing that you're doing in parallel. And when you have a vtable, in other words, when you have a reusable interface, such as allocator or IO, you're going to have a function whose value is known at runtime. The problem is we need to know upper bound stack usage of that function. But if you only know which function is being called at runtime, then you're going to have you're not going to know the upper bound stack usage. There's also a problem with recursion, which we can get to in a minute. What this proposal accomplishes is it means that you'll be able to mark functions as being it means that the compiler will be able to automatically determine that a given function pointer can only be one of a limited set of things. And because of that, it can say that the stack upper bound usage is the maximum of them. And that allows you to pre-allocate all the possible function call stack that you need in order to do something in parallel. And if we didn't have everything in one compilation unit, then we wouldn't know, we wouldn't be able to do this proposal, because you wouldn't be able to know what, you wouldn't have a closed set of possible functions that a function pointer could point to. Is this something I should click? Oh yeah, this is the safe. I know like a set of Zig issues with just by number. I think this one's called like safe recursion. Yeah, I got it. Yeah, that's related for sure. Yeah, so that's where we're headed. And in the meantime, the reason that it's been taking a while for this branch to make progress and get merged is because I'm also I'm changing standard.io.reader and standard.io.writer. I'm preparing them to be assimilated into this pattern and into the async await pattern. And that's unfortunately quite an involved change. But I've switched tactics recently to try and do this more piecemeal, so I'm expecting to make progress on that soon. But I have to say, I'm sorry, but you have to prepare for some major breakage, because changing standard.io.reader and writer, it really it basically just makes you like fully rewrite any code that touches it, and it's a huge pain. So I'm sorry, but I'm strongly convicted that this is the future. It's going to be great. I'm sorry that I didn't get it first try. I think this is my like 4th iteration on async await. I really tried a lot of other things first. Yeah, I don't know. I'm not smart. I just try a lot and never like settle for something that's not perfect. That's the only like thing I bring to the table. So that's the downside, is a lot of breakage. So I'm truly sorry for that. But I really believe in this being like a good strategy for the future, and I'm really excited about it. Yeah. All right, let's see if there's any questions here. Does this mean that async await won't work across dynamically linked library boundaries? Kind of. So you can annotate extern functions, and then you'll be able to have them called. But it's kind of the same problem that like outside of like if you have an event loop, you really don't want some third-party code to then do a bunch of like file system reads and writes outside your event loop. It kind of defeats the purpose, right? You need it to participate in the system. So it kind of creates that problem. However, because we have I/O as an interface, one thing we can do is we can implement and for some targets we actually control the libc code too. We actually can provide libc functions that then actually just call into the I/O interface. And so in some cases, we actually would be able to make this situation work optimally, because as long as we can calculate upper bounds on the stack of the functions that are being called, and as long as we can control like the I/O, then we can totally make it integrated. But there is also still the possibility that like you can just write some code that does the wrong thing, right? You could literally just write a function that says like crash the program and put that in a dynamically linked library, and then like, yeah, if you call that, you're going to crash the program. Or if you just put like sleep 100, you're going to mess up the event loop, you know, in that code. So in other words, there's definitely a potential for code on the other side of a dynamically linked library boundary to not work. However, there also will be a lot of tools to make it work if you try. I hope that answers the question. Will there be sync and async reader and writer? So yeah, I didn't explain this very well. So the way that this is going to work, the way that I tried to make this work in the past was by like making everything generic. So you'd have the same code, but then it would get instantiated in a sync way, or it would get instantiated in an async way. What I've moved towards instead is a non-generic approach. So the new writer and reader interfaces, for example. Let me before I switch, let's look at the current one. So let's look at writer, for example. How does this work? Okay, this is kind of like the writer. I wrapped it around this anything, but it's really not a good idea. So forget about that for a second. This is basically what everyone uses as generic writer. And it's relying on generics, obviously. Okay, now let me switch branches. I'll show you briefly what I'm working on. Okay, so the new writer is not generic. So this is just a file. This is a struct. It's got some fields. And when you want to satisfy this interface, you have to provide you have to provide this function and optionally these functions, which have defaults. And if you do that, then you get all these methods for free. And what's nice about that is that all the code in this file is not generic, which means that the same machine code, you'll notice a lot of it is formatting code, the same machine code will be used in all of the writers in all of the streams. So there's no opportunity here for this to be generic, or in other words, instantiated in an async manner, or instantiated in a sync manner. So where was I going with this? So my point is that it all depends on how you implement the I/O interface. So if you implement the I/O interface, for example, in a single-threaded blocking manner, then you're going to get single-threaded blocking code here. Like you're going to implement drain, and well, in many cases, you actually just chain these things together, right? So like, for example, if you have a compression stream, then you provide a writer that you can write bytes into the compression stream, like gzip, for example. You provide a writer so that you can push bytes into it, and then you also are given a writer that you push bytes out to. So it just kind of lives in this kind of chain. It actually doesn't need to know about I/O at all. You can just make it almost like a pure function, in a sense, right? It just takes in the bytes, it does something, and it pushes out the bytes. It doesn't even know about the operating system, doesn't know about I/O, blah, 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 blah. In some cases, though, you're kind of at the end of the chain. So, for example, the implementation that is in file. So this is the writer that provides the writer interface. But at the end of the day, it has to write to an actual file. It has to actually do, like, POSIX.write v, for example. What's my point? My point is that this interface, this implementation of writer will need an I/O interface. It'll have to be given one, and then it will decide. It will be calling IO.write v or whatever, and that call will determine whether or not the drain function is async or sync, and then the restricted function pointer types will be able to do, just like it takes the upper bound of the stack, it will take the, like, if they're all sync, then it makes them all sync, but if any of the functions are async, then it makes the function pointer async. And because it knows that they can, anyway, the point is it has enough information to make it all work. And we don't have to implement stackless coroutines for this to already be useful, because we can even just provide a thread pool implementation, we can provide a single threaded blocking implementation, we can provide a green threads implementation, and those are already like extremely useful. And then we can additionally provide a fourth implementation based on stackless coroutines later, enabling more use cases that weren't possible before. But it's already enough. It's already, the concept is proven, like we know it can work. There's not a danger of that not working. So it all depends on the I/O implementation, what you do, basically. And the point is reusable code. Like, you can see it right on the home page, right? Like, what's the point of Zig? It's a general purpose programming language for maintaining robust, optimal, and reusable. Reusable is super important. All three at the same time. The point is you should be able to make a package that is not only robust and optimal, but at the same time is also reusable for everyone else. Even if they're on the hobby operating system that they just wrote yesterday, they should be able to use your, I don't know, like JPEG package that you made 2 years ago. They shouldn't have to add like special support. It should be reusable code. Not only reusable from source code perspective, but also, in this case, literally reusable machine code. Like the same, ARM64 machine code that this generates will be used in the binary under like multiple conditions. So there's kind of like two reusable code angles to that. All right, I hope that made sense, and it's a little bit rambly. Okay, let's move on. I know people probably have questions. Keep the questions, and we'll do an actual QA session momentarily. Yeah, actually, I only have one more topic to get through, and then we'll do QA, and then I think I have one more announcement, and then we're done. Okay, so next. Ask me this later. I can go over this. That's a good topic. But before we do that, let's move on. So let's go back to master branch. Let's talk about fuzzing. Now, unfortunately, I haven't had a lot of time to work on fuzzing. Okay, good. Keep those in mind. We'll get there momentarily. No, I haven't touched this in a while, but it is definitely, most certainly, part of the roadmap, because I dipped my toes into fuzzing a little bit. Thanks to Loris for getting me kind of like showing me the ropes with AFL, and I read the AFL source code, which is pretty neat. and I started working on an in-house fuzzing toolchain. And I'm now, before anyone says "not invented here" syndrome, like, sure, we're definitely guilty of that, proudly guilty of that, you might say. But man, having an in-house fuzzing toolchain is going to be a game changer. Like, there is so much you can do with in-house fuzzing. Like, the worst thing about fuzzing is how annoying it is to set up all the infrastructure around it, and like, it's a total pain in the ass. But people still do it because of how much value it provides. So if we can have integrated fuzzing with Zig, it's going to be crazy. Like, it's so convenient. Like, people will... it actually saves you time, because you can write 100 unit tests and spend like weeks on that. Or you can just write one fuzz test and then delete 99 unit tests. It's so good. But in case you didn't see what is done and what is available, I think we have something in the like hello or the init template. Let's go in here. So I don't know, maybe I broke this because I haven't touched it in a while, but let's take a look. So this is our init project. Let's do Zig build. What are we doing here? Okay. Oh, big help. That's what we're supposed to do. So this project offers us run and test. Let's do test. This is our init project. I think Loris worked on this recently. Okay, that seemed to work. I don't see the text one fuzz tests found though. I wonder why. I was expecting to see that. But anyway, if I look at the source code, I see try passing fuzz to Zig build test and see if it manages to fail this test case. Let's try that. So when you do fuzz mode, it actually runs unit tests once, finds out which ones are fuzzing test cases, and then rebuilds your unit tests in fuzz mode, which instruments the binary and also does things to help fuzzing work better. And this is a regression in the build system. So I think I probably broke this. But you can kind of get a little sense of what's going on here. It actually creates a web interface that displays your source code using the same logic, the same like WebAssembly binary as the autodocs, and it shows these little like traffic lights, you know, red or green depending on whether the fuzzer found that line of code or not. I think, let me try just one thing really quick. Wrong. Seems to be like a debug info issue. So I'm just gonna try different release mode. You generally want to run your, oh, there we go. You generally want to run your fuzz tests in release mode because you want more iterations. I haven't played with this in a while. I imagine it might be broken. Okay, there does seem to be a problem there. Okay, well, you can kind of get the idea. So it puts these little lights on like areas of interest, and if it got run, it turns green. So I think something regressed because at one point in time, it would basically just find this password instantly. But yeah, like I said, unfortunately, I've been a bit distracted. So it's just all very experimental. But it is relevant for the roadmap because it is something that I fully intend to get back to. My plan is to make... oh, Casey Banner already knows the issue. Okay, let's take a look. Okay, well, we can look at this later. What was I saying? Yeah, so it's extremely experimental. It's just dipping my toes into this thing. But man, when we have this thing like full, like when we're ready to say that this is like ready to go and it's ready for prime time, this is going to be game changing because if you've never played with fuzzing, you should try it because it's incredible. Like the genetic algorithm just figures out how to exploit your code. It figures out which inputs are good, and it's like find your bugs before your users do. It's like, you don't need a bug tracker. Just find all your bugs. It's so good. So that's where we're gonna go. Yeah. So unfortunately, small team can only do one thing at a time. Lots of big things to do, but it's coming for sure. It's coming for sure. That's the point. Okay. Okay, well, I think that was pretty much everything I wanted to go over as far as demos and roadmaps go. So I think we're ready for doing community announcements. Now, I think I know one of them, Loris, but is there another set of community announcements? CDMs. Okay, yeah, figured. Okay. Why is my... Oh, there we go. Okay, I got the list. Right. Okay, 3 announcements. Number 1, if you might notice this new little thing here, setting up automation. If you are setting up your CI and you want Zig on there, have a look, because you can... well, you probably don't want any downtime on your CI, right? So you might want to have a look at community mirrors. This is a way for if you want to volunteer and run a community mirror, you can help ZSF by just mirroring the tarballs. And if you are a user of Zig and you just want the tarballs, you can get faster downloads and avoid downtime by integrating with community mirrors, because we do not guarantee an upline. We do not guarantee a uptime on zigling.org. We do our best, but we optimize for running on a cheap computer and not worrying about it too much. We don't. No one's on call. We don't wake up in the middle of the night if it goes down. So use mirrors if you want your CI to stay online. And some people are already running mirrors. Thank you for that. Let me just take a look. So yeah, thank you to Emmy. Thank you to Stevie. Thank you to Linus Grow. And thank you to Silver Squirrel. Yeah, more details on that page. Okay, next we have... okay, I already made this announcement at the beginning, but let's make it again at the end. Oh, also thank you to Frank once we fix our own TLS implementation. Yeah. Okay. In case you missed it at the beginning of the show, Software You Can Love Vancouver 2026 has been announced. So I think there it is. The only .Canada website I visit. Okay, so the website's not up yet. This is 2023, but it's official. Matt Knight is planning a Software You Can Love 2026 Vancouver. So just get ready. I don't think there's any call to action items beyond heads up. Yeah. Funny story, Soapbox Rager, because we actually have a here, let me show you. We actually have a Vancouver north of Portland, but you have to keep going to Seattle and then keep going to get to the real Vancouver. But when you drive home from Software You Can Love, you leave Vancouver, and then it says, and then there's a sign that says like "Welcome to Vancouver." It's really trippy. Okay. Anyway, if you come to that, 2026 should be fun. We had a good time last time, and I think Matt Knight has some nice ideas for how to take it to the next level this time. And also, if I understand correctly, Loris is also helping organize it. So it should be nice. And finally, we have Zig Days. So zig.day, that's a new website. Oh, you know what? Shoutouts to my wife for making her first ever pull request ever, which turned these little pins into these little zero heads. Okay, so this is a new thing that we're doing. There's a format for meetups that Loris and I are a big fan of. And the format is, instead of sitting around and listening to people talk all day, what you do is you meet up early, like 9 a.m., and you do a little icebreaker. You talk, 30 minutes, you get to meet people a little bit, talk about what you're interested in. You go around the circle, and everyone talks about things that they tentatively plan to work on that day. Everyone brings their laptops. Next, you sit around a bunch of tables, and people form groups. So if you want to go join someone else's project, you can just do that. So then people form groups, and then for one day, you just hang out with each other and hack on stuff. And then at the end of the day, you, again, before you, like at 5 p.m. or something, before you disperse, you get together again, go around the room again, and everyone just talks about what they learned that day or what they did, or just takeaways from their little hack session. I personally think this is a really fun format for a meetup. And so I am looking forward to hosting one in my hometown, or not my hometown, but my current town that I live in, of Portland, Oregon. So we didn't schedule an event yet, but my friend Mason is going to help me organize, and we're thinking soon, like within a couple months. I believe Milano just had one recently. Yeah, May 17th. Nice. I guess this shouldn't say upcoming anymore, huh? And I don't think San Francisco is ready to go yet, but what about Vancouver? No events planned yet. So this is kind of like an up and coming thing that we're starting to do. We're hoping to have our first Portland one, within the next couple of months. And there's one more point I wanted to make. I don't know. I forgot. Sorry. Right. The point I wanted to make is this website is also a call to you. If you want a Zig Day in your town where you live in, you can be an event organizer, and Loris will give you kind of like code owners of like the subdirectory of your city, and then you can kind of just run the event, and you can edit this website with automated pull requests. I believe that's how it works. And then people who want to come to your event, for example, they can get notified and subscribe. So you can take advantage of this platform to help get your meetup bootstrapped. So, point of this announcement is to entice people who want to organize an event to do so. Let's get some more Zig Days going, yeah. And of course, you can put your own flavor on it. You don't have to do exactly the thing as I explained it. Each event has email updates, RSS, and also an iCalendar. The link down here tells you how to become a Zig Day organizer. Yeah. All right. So that's Zig Day. And with that, I think we are ready to go into Q&A. So go ahead, hit me with them. This is where previously Loris was going to do the what's it called? Choosing of questions to ask me, but I guess I'm the one in charge now. Oh, we forgot about Zigtoberfest. Okay, sorry. One more before questions. Okay, Zigtoberfest. Yes. Oh, look, an up-to-date website. That's nice. Right. Oh, cool logo too. So this is a event. I believe it's a 1-day conference, and this is in was it in Munich or Berlin? Munich. The people who went last time, they said they had a good time. It seemed pretty fun, and I think it's mostly talks in the beginning of the day, and then maybe you go get some dinner after or something like this. Is there anything? What else is there to say about Zigtoberfest? Oh, there's recordings from the previous ones. I don't know. It could be a nice event to go to if you're in the area. Oh, and it's at University of Applied Sciences. Specie and pretzels. Oh man, that's making me not want to go, to be honest. Okay, well there we go. It was nice last year, despite the specie. Okay, let's move on to Q&A. So let's see here. Here's a question. Is stage 2 compiler the same as stage 3 for x86 64 Linux debug builds? If you're talking about literally this binary, this one, this binary is created by compiling this file. So if you want to know more about this, I suggest to read this blog post. This explains how we bootstrap. This explains how we build from source after we got rid of our C++ code. And so yeah, basically this file is created from WebAssembly, and then we create this, and then this creates the final one, and then from then on it doesn't matter, like if you do a fourth one you get the same results out again. Are timeouts in async code going to be handled through user provided cancellation logic? Oh yeah, that's a good question. So basically every function that does IO gets an additional error in the error set called canceled. So pretty much so your function's gonna have to take do thing. You're gonna have to take an IO parameter. I don't know, like read file or something. So you're gonna get this error set, right? And there's a bunch of different ways that reading a file can go wrong. Now there's going to be an additional way that that can go wrong, and it's canceled. So you're just going to have to handle that, or usually just don't handle it, right? You're going to just it'll just be part of your else return. So now you're going to also have canceled in your error set, or it can obviously just be inferred. And so that'll just bubble up correctly. And because it's an error, if you have any error defer blah blah blah, this is going to run in case your IO thing gets canceled. It's kind of beautiful, isn't it? Actually works extremely well. And our proof of concept, by the way, we have a proof of concept with IOU ring, and canceling stuff, really cancel stuff. It sends the syscall to the kernel to cancel an in-flight queued operation in the uring. Okay, so I want to just keep the chat alive by not scrolling up. So if I didn't answer your question, can you please just repeat it? And then I'm just gonna miss stuff, just repeat it every 5 minutes or something. Does that sound good? Right, so there was a question about function coloring. I want to address that. So you can think of taking a allocator as a function coloring thing. because let's say that you want to call foo, yeah, from do thing. Well, I actually can't call it because I don't have an allocator. So I kind of gotta have one. And now I can call foo. So that is kind of a form of coloring, I guess. But to me, this is a fine form. Like, it's not a problem. What I didn't want was to have this function. Like, you know how like in Rust there's, what is it, like async standard library or something? Oh, that's not how you spell that. Okay, so this thing, which is not official, by the way. So this is docs.rs async std. Yeah, look, see, this is not Rust. This is like a different group of people, I think. But anyway, my point is, that's what I don't want. That's function coloring, right? Like the fact that you have to have two standard libraries. I want one standard library, and I want it to work in a event loop context, and also in a single threaded context, and also on WebAssembly, and everywhere. So I don't know, like what is or isn't function coloring? It starts to get kind of like academic, doesn't it? Like really, the point is reusable code. That's the actual point, and this pattern does enable reusable code. Yeah, I agree with this take. So yeah, the problem with like function coloring is code duplication, not reusable. So as long as you have the same implementation, fulfill all the use cases, you're good. And then yeah, who cares whether it's technically function coloring or not? Not the point. Okay. Oh, here's one. Is there any big changes planned for the Zig build system or package management? Well, there's plenty of things that have been important things that are not done that have been planned for a long time. So for example, if I look at build system and enhancement, and maybe like author me. So there's quite a few things here, especially if you kind of go to the older ones. I would say that some of these I would call big, you know, for example, yeah, like running build.zig logic in a WebAssembly sandbox, that's kind of big. It's also very breaking. I guess there's plenty of ideas here, and a lot of these are planned and they're just not done yet. So like, for example, Zig build system has some really serious limitations that we're all just kind of putting up with right now because more work needs to be done. And we'll get there. But like, for example, detecting when a dependency has an update. Basic stuff, we don't have that yet. Dealing with breaking changes in a dependency, and not having like a pain in the ass way to patch only one thing. There's all these workflows that we have good solutions for, like in theory, like we have vaporware solutions for, but they just need to be implemented and they're not done. So in other words, is there any big things planned? Well, yeah, the same things that have been planned for a while and just aren't done yet. You can see a bunch of these issues were opened, you know, like years ago, and like we'll get there. It just takes time, you know, and we'll try to do the most important stuff first so that people can get unblocked. And you know, I think that I know a lot of people are waiting for 1.0, or at least they say they are. They're saying, well, you know, once Zig hits 1.0, then I'll jump in, and that's understandable. That's reasonable, but my goal personally is going to be to make Zig so compelling and so useful that people are willing to put up with not being 1.0 yet, because it's still worth it. It's still so good that they're willing to put up with the instability. That's my goal. Because I don't want to tag 1.0 until it's ready, and it's not ready yet. What's the blocker for getting the x86 backend to work with LLD? I don't know the answer to that question, but to be honest, I'm not going to work on that at all. I'm instead going to work on eliminating LLD completely. It's not too much work. Like we could trying to take on LLVM, that's a super long, years long effort. Trying to fully subsume LLD, that's accomplishable pretty soon, So I'd rather just kind of do a sprint on just eliminating cough LLD dependency, and then that question just doesn't matter anymore. You know what I mean? That's kind of like my avoid local maximums mantra. It's like, I'm just not going to spend any effort on that. I'm only going to spend effort climbing the big mountain, if that makes sense. How would things like mutexes, futexes, etc. work with new I/O? Is there any plan to control the cache size for incremental? Let me address that second one first. So I think you're noticing that incremental is using a lot of Zig cache size. And the reason for that is incremental is designed to, obviously, take an already existing output and then minimally mutate it to the new state. So you build something, you make an edit, then the compiler makes a minimal edit to the output in correspondence with the edit. That doesn't fundamentally produce a lot of cache garbage, but because we don't yet have robust state saving for incremental compilation, the default cache mode that we use creates a new artifact every time, which can build up a lot of trash in the cache. So again, I'm not going to solve that problem by trying to, I don't know, mess with how much size things are. I mean, we already optimized that a lot, but my point is, the thing to work on there is finishing the state serialization so that we can go back to the default where when you use incremental mode, it just updates your already existing binary. It doesn't create a new cache entry. And then that will stop creating garbage because it'll just keep editing the same file over and over again. Let me get your other question too, because that one was also quite reasonable, I think. Where was that? Oh, no, I lost the other one, sorry. Oh yeah. How does mutexes and futexes work with new I/O? They're part of the I/O implementation. So the okay, so the interface, this is the part that you interact with as a user, has to define like a mutex. And this, I guess we have two possible implementations here. So we basically just define mutex as like an integer, and then a I/O implementation gets to use that integer, and they have to fulfill mutex lock and mutex unlock vtable functions. So but the important point here is that the locking is implemented in the interface, so it does have to coordinate a little bit with the implementation. So it is a little tricky. So the interface has to have the state. The state can't be on the other side of the vtable, and so then in lock, it tries to do the lock without calling the virtual function, and then if it can't, then it calls into the implementation there. So there's a little bit of coordination that we have to do. Like the implementations do have to satisfy like a certain ABI kind of, but there's some ways we can tweak this, and ultimately it works fine. So then you can in this function you can implement it in a way that integrates with your I/O implementation. So if that's a thread pool, you literally just lock a mutex, If that's like IOU ring, you actually just yield and start doing something else, and then you try to, and then you don't even schedule the fiber until the mutex gets unlocked. It's pretty nifty. So the mutexes will work like correctly according to the like IO implementation that you pick. Is the file system watcher code accessible from STD? Okay, I understand this question. So in the build system, we have, let me go back to the main branch. So in the build system, we have this this code which implements file system watching, and as you can see, it requires like different logic on Linux or on Windows or on here, where we have only KQ, and on macOS it has that limitation about whatever that thing is. So the question is like, can this code be more general purpose? And I understand the desire for that, but having used these APIs a little bit, I kind of think that file system watching is just like not very abstractable. I feel like whenever you do file system watching, you kind of have to tightly couple with the application logic. It's just, unfortunately, it's just kind of a resistant topic to abstraction. So I have no plans to try to like generalize this and put it in the standard library. I think that answers the question. Loris, did I miss something good? How am I doing on QA? Shouldn't the allocator also be part of the I/O interface? Couldn't getting memory also block on some systems? Also, memory kind of is external in a sense, as files are, for example. So basically writing to memory versus writing to a file, for example, could be seen as I/O, like if you memory map something. That's an interesting point. Also, in just in kind of like collaboration with this question, if we look at the implementation of a MN like green threads event loop, we do have to allocate memory. So for example, like where do we even get an allocator from? Oh, okay. So we actually just have to pass one in on initialization, and it has to be thread safe. It is pluggable though, could just be kind of any allocator. So I don't know. I could maybe see well, no, actually, I think here's one answer to this question. One valid implementation of I/O is, again, single-threaded blocking eager. So whenever you call async, it just does it. And then this is nothing. And then when you do this, it's always a no-op. Okay? Cancel does nothing. This does not, This does nothing, this does nothing. Mutexes do nothing, conditions do nothing. These just do everything immediately. You get the idea. In such a I/O implementation, which is totally a valid implementation of this interface, you actually don't need an allocator. It would be kind of inappropriate to put an allocator in the interface in that case. Like, what would it? Like, it would expose memory allocation functionality and then nothing else. Like, nothing else depends on memory allocation. So that's my argument for why it does not belong in the I/O interface. So it's kind of, I think people have a tough time with like, well, it's so big, right? There's going to be so many functions in here, and like, yeah, it's going to get a lot bigger. It's probably going to take up like multiple screens with how much functions are in here. But I actually don't think allocation is going to be in there. I think that's actually a lower level primitive that doesn't fundamentally relate to I/O. Even though all these other things kind of like counterintuitively do relate. That's my current opinion, but we can see how the situation turns out. Okay, so here's a question. Reader has a vtable and reader has a vtable and IO has a vtable. Does that mean each read op goes through 2 levels of virtual function call? Oh, that's a good question. Yeah, I'm pretty sure that does mean that. It's going to be 1 virtual function call per stream, right? Because also if you chain streams together, like if you take like a network socket reader and then you pipe that into like HTTP and then you pipe that into like gzip or something, every time you do that, you're going through 1 like virtual function call. And so yeah, 1 for, and then at the very, very end of the pipe, you're going to be plugged into an IO, probably at the beginning of the pipe and at the end of the pipe, right? So you're going to have 1 virtual function call into IO at the beginning of the pipe, probably like to read from the socket or something, and then 1 at the end of the pipe, like maybe you're writing to the file or vice versa. I think that answers the question. Oh yeah, and then also related to that is devirtualization. Yeah, and this is where this thing comes in. Restricted function types. So if and this is critical. So if you only have 1 IO implementation in your program, which is the common case, it's not necessary, but it is the common case, then your restricted function types for your vtable will all have exactly 1 possible callee in all of the function pointers. And so those basically become non-virtual, like for free. Like I'm not talking about an optimization going in and detecting this. I'm saying that like the front end of the compiler will just spit out a direct function call because it knows that actually there's only 1 implementation for this given like function pointer. Yeah, that's a great point. Thank you. Oh, so many good questions here. How am I doing? I feel like I'm getting a little tired. Like been talking for 2 hours, Ugh. Loris, do you have any suggested questions that I missed? I've been kind of I'm happy to do a couple more. I've just been kind of missing a lot, so I don't know what I missed. Oh, this is a good one. So what's on the more medium to long-term horizon? So not what I'm already working on, but like maybe tackling after the immediate priorities are handled. That's a good one. Okay, so immediately is streams for me, followed by like async IO stuff, and then fuzzing. We already talked about all that stuff. Okay, yeah. So I am looking forward to getting more done on my music player and my music production software. I've been kind of unmotivated to work on those like right this month because I really want to use this async stuff in them. So I think I'm going to want to work on that more, and that's going to make me want to do it's a web server, so it's going to make me want to do a little bit more like web server stuff. I actually think Zig can be a great fit for web programming. And that's a good one, yeah. I think right now it's not great, and I'm not like super happy with standard library APIs related to web stuff. But contrary to popular opinion, I think like once we kind of get the standard library worked out and the async story worked out, I think Zig's going to be really nice for web development, for like servers, and and for the front end if you're using WebAssembly. And so I kind of want to, I guess I want to get more into the ecosystem, like I want to be a user of Zig. I want to use Zig to make a useful application that users use to make music or to listen to music, and help out with the ecosystem and like make the package manager like really convenient to use and stuff like that. So probably for me, just getting more into like being a user in addition to compiler dev, you know? Hope that answers that. Pin structs. Okay, so pin structs. The primary motivation for pin structs was async await. I think this was an accepted proposal until recently. Ta-da. Now, the new strategy for async await does not require pin structs. So that pin holding the feature in place is now gone. Additionally, speaking from experience, the compiler code, not just the implementation, but also as a user reading the code, it did become a lot more complicated in order to understand result locations. And I'm not talking about types. Those are pretty handy. I'm talking about pointers. So the idea that if you like return, then if you do like assignment, for example, then like the expression gets the pointer of the assignment result, and then if you have like a sub expression, it kind of gets forwarded through the result and stuff. Also, a lot of people like to complain about this because it can result in like aliasing problems, which is annoying. So wouldn't it be nice if we just didn't have that anymore, because we don't need it anymore. So that's kind of the like reason that this is now up for discussion again, and not already decided. And as usual, the default in Zig is no to any new feature. So you have to win against the null hypothesis of don't complicate the language. So in order for this to be accepted again, there would need to be a compelling reason to add a feature to the language that is actually not really needed in order to accomplish any of our goals. Feel free to ask a follow-up question about that. I hope that's enough. Any plans for syntax sugar for the vtable based interfaces? Still no. I'm actually pretty happy with status quo, having just done a lot of work on interface design. Oh, I have tea here. Oh, that's nice. One thing in particular that I noticed is that let me give you an example. So I'm going to go over to this branch again. This one. Now, what you're seeing here is a manually constructed interface. So in other programming languages, they would just have like the keyword interface, or it would be a trait, or something like this. And there's certain rules what you can or can't do. So for example, if we look at the equivalent like Rust trait, brighter. There it is. Okay, so this is the right trait. Cool. You don't get to create like, this field. In fact, you don't get to create any fields because they've decided that you can't have fields on traits. And I'm sure there's a really good reason for that. But that's a decision that limits what the programmer can do. Now here, we don't have this limitation. So what I've done is I've actually pulled these buffers from beneath the vtable to above the vtable. In other words, they're here, they're not inside. So whereas previously we would have to create kind of like a buffered writer as a kind of like thing in the chain, it sits instead above the interface, or in the interface. It's not in the implementation, which means all these functions down here that are not generic and that are not virtual, all these functions are in the interface. So for example, write byte. This is an important one. The likely condition for this is that it goes here. And all it does is just update the buffer, update the counter, and then return. And this can get inlined, and the optimizer can fully understand it. Static analysis can fully understand it. And it only goes into the slow case if we run out of buffer. Point is that it doesn't make this function call. Only it rarely makes the virtual function call. And that's true even if we're sharing this code through the entire program for 100 different IO streams. We don't have to create 100 different versions of write byte. The same version of write byte can be reused and it's still efficient. And it's because we put the buffer in the interface, not in the implementation. So that's why you will not find a buffered writer, because the buffer is in the interface. And you can see it's referenced all over the place. Where was I going with this? Right. My point is, you can't do this in other programming languages because they don't let you do it. But here we can. And the only reason that I just got to play with this is because I didn't give myself an interface, that prevented me from doing that. So I actually think it's nice to build your own interfaces. And furthermore, I think it's the appropriate amount of friction. I think that creating an interface should be kind of annoying, and you should have to put a lot of thought into it, and you should just usually simply not do it. And so I'm actually quite happy with status quo. And I like doing this chore of setting this thing up was not the thing that took a long time in this branch. No. It was editing all of the usage code to follow the different semantics. So I'm still pretty keen on not adding any object-oriented programming, basically, is what I'm saying. Okay, well, I should probably get to this topic then. I think, let me do one more. We'll do one more, and then we'll wrap up with this. So let's see if there's a good one to end with here then. Okay, let's... Wait, I'm trying to parse this one. How will tightly integrating other operating systems with the standard library work apart from... Okay, if I understand this question, it's kind of asking, is implementing the I/O interface 100% of porting to a new OS? And if not, what's not included in it? I think that's kind of what you're asking. Yeah, that's a great point. I think that porting an I/O implementation to a new operating system should be almost all porting work. I think there should be very little beyond that. But your I/O implementation is still going to depend on operating system bits. So for example, let me switch branches once more. So here we have, here we have an IOU ring implementation of I/O, and my point is simply we need to call into IOU ring in order to do this. So this implementation depends on standard.os.iou ring. So you could kind of call this just the I/O implementation, but my point is you have to go implement all these bits that this code is going to call into. Likewise, in the same branch, we have thread pool. Okay, so the thread pool, it's not only for one operating system, it's for multiple operating systems. But in this case, we depend on standard.thread. And standard.thread obviously is going to have to do operating system specific stuff in order to spawn a thread. So we have a Windows implementation, POSIX, a Linux, a WASI. You get the idea. So Yeah, I mean, it's mostly just implementing I/O, but that does involve just kind of a bunch of different little bits and bobs, and those got to go somewhere, and maybe those go in different files. I think you get the idea. Okay. Yeah, I think I'll start wrapping up then. And so finally, yes. How do we support financially the ZSF? Right. So for those who don't know, Zig project is managed by the Zig Software Foundation. This is a 501c3 non-profit corporation, not to be confused with a 501c6, which are allowed to lobby the government. We are not allowed to lobby the government. We are apolitical. We are just trying to work on software. I'm due for making another one of these blog posts, so I need to do the one for last year. But here's the one from last year. So you can look here for our 2024 financial report. I'll do another one soon for 2025. But you can see how we spend our money. You can also see how we get our money. And we do like to try to keep a good slice of this as individuals. So GitHub sponsors, individuals, Benevity. It's good to be independent, you know? And so whenever we get individuals doing sponsorings of us, it makes us very happy because it helps us to keep a diversified income and stay independent. So we really appreciate all the individuals who sponsor us. Yeah, and if you want to help out, that's honestly the best way you can help out. Like, we got people chomping at the bit for ZSF contracts, and if we have more money, we can give out more contracts. How'd I do, Loris? Are we good? Okay, yeah. There's also, whoops. I guess I'll just go navigate to these links then. Every.org, Zig Software Foundation Inc. Yeah, so you can also go to this platform. We like every.org. Every.org is pretty nice. It's also a nonprofit, and so it's not. Yeah, we're a little bit worried if Microsoft decides to cancel GitHub sponsors or something, we lose a lot of income. So we feel that this one is a little bit more stable. That's our primary preferred way to get money, but every way is fine. You can also do you can also do GitHub sponsors, which is also fine if that's what's easier for you. Great. Yeah, really appreciate that. And if you can convince your company to kick us, $1K a month or something, if you use Zig at work, then awesome. Really would appreciate that. But either way, we'll figure out the money thing, and we'll make sure that we stay alive and keep making Zig better and better for everyone. Okay, I think that's it, everyone. Thank you so much for visiting. Thanks for following along, and happy hacking. Yeah? Take care.